grounding configuration relying solely on the solid strand cable to the power pole is inadequate and potentially dangerous. According to modern electrical codes, all electrical systems must be effectively grounded using copper grounding rods and/or water pipe connections. The incorrect connection of the ground wire to the neutral lug at the meter is a major issue. This creates a dangerous condition where current can flow through the neutral wire instead of the intended ground path. The jumper connecting both breaker lugs in the main panel is also incorrect. It essentially defeats the purpose of separate breakers by allowing current to flow through both circuits even if one breaker trips. The capped-off red wire should not be left loose in the box. It should be properly terminated and connected to the unused breaker lug if required. To correct this, firstly, remove the ground wire from the neutral lug. Secondly, connect the neutral wire to the neutral lug. Thirdly, connect the red wire to the other hot lug. In the main panel, firstly, install a copper grounding rod and/or bond the panel to the water pipe. Secondly, remove the jumper connecting the breaker lugs. Thirdly, connect the red wire to the unused breaker lug. Fourthly, connect the neutral wire to the neutral bar, which is bonded to the grounded panel. The 100 amp service may not be sufficient for current and future electrical need. Consider upgrading to a higher amperage service such as 150 amps or 200 amps. Have a qualified electrician inspect the entire electrical system to ensure it meets current electrical codes and standards. Always turn off all power before working on any electrical wiring. Use appropriate safety gear, including gloves, safety glasses, and non-conductive tools. If not comfortable performing these corrections, hire a licensed electrician to ensure the work is done safely and correctly. Grounding is a critical aspect of electrical safety, ensuring that, in the event of a fault, current has a safe path to return to the source, tripping a breaker and preventing electrical shock. The grounding system typically consists of a grounding electrode system, which includes grounding rods, water pipes, or other approved electrodes connected to the electrical panel via a grounding electrode conductor. The neutral conductor is also bonded to the grounding system at the main service entrance, creating a single point where the neutral and ground are connected. This bond is crucial for proper operation of overcurrent protection devices, such as circuit breakers. When a fault occurs, the current will flow through the grounding system back to the source, causing a large current flow that will trip the breaker, disconnecting the circuit and preventing potential hazards. In an older home, like a 70-year-old house, the original wiring may not meet current safety standards. Cloth-wrapped wiring, commonly used in older homes, can become brittle and deteriorate over time, increasing the risk of shorts and fires. Replacing this old wiring with modern, insulated wiring is essential for safety and reliability. When upgrading the wiring, it is important to ensure that all connections are properly made and that the correct wire gauges are used for the intended load. Overloaded circuits can cause wires to overheat, leading to insulation damage and potential fires. A subpanel is an additional electrical panel that is fed from the main electrical panel. It is used to provide power to specific areas or appliances, such as a workshop, garage, or air conditioning unit. When installing a subpanel, it is important to follow all applicable electrical codes and safety standards. The subpanel must be properly grounded and bonded, and the correct wire gauges and overcurrent protection devices must be used. The subpanel should also be labeled clearly to indicate the circuits it serves. The National Electrical Code, or NEC, provides comprehensive guidelines for electrical installations. It is updated every 3 years to reflect advancements in technology and changes in safety standards. Electricians and electrical inspectors use the NEC to ensure that electrical systems are installed and maintained safely and correctly. Some key aspects of the NEC include requirements for grounding, wiring methods, overcurrent protection, and equipment installation. Adhering to the NEC is essential for preventing electrical hazards and ensuring the safety of people and property. When working with electrical systems, it is crucial to follow all safety precautions. Always turn off the power to the circuit before working on any wiring. Use appropriate safety gear, such as gloves, safety glasses, and non-conductive tools. If you are not comfortable working with electricity, hire a licensed electrician to perform the work. Electricity can be dangerous, and it is important to take all necessary precautions to avoid injury or property damage. Common electrical issues in older homes often include outdated wiring, insufficient grounding, and overloaded circuits. Outdated wiring, such as cloth-wrapped wiring, can become brittle and deteriorate over time, increasing the risk of shorts and fires. Insufficient grounding can prevent overcurrent protection devices from operating properly, increasing the risk of electrical shock. Overloaded circuits can cause wires to overheat, leading to insulation damage and potential fires. Addressing these common electrical issues is essential for ensuring the safety and reliability of the electrical system. Upgrading the electrical service involves replacing the existing electrical panel and service entrance wiring with a higher capacity system. This may be necessary if the current electrical service is not sufficient to meet the electrical demands of the home. Upgrading the electrical service can provide increased capacity for new appliances, air conditioning units, and other electrical equipment. It can also improve the safety and reliability of the electrical system. When upgrading the electrical service, it is important to hire a licensed electrician to perform the work. The electrician will ensure that the new electrical service meets all applicable codes and safety standards. When connecting wires, it is important to use the correct type of wire connectors. Wire connectors are designed to provide a secure and reliable connection between wires. Common types of wire connectors include wire nuts, crimp connectors, and terminal blocks. Using the correct type of wire connector is essential for preventing loose connections, which can cause overheating and potential fires. Wire nuts are commonly used for connecting wires in electrical boxes. They are available in various sizes to accommodate different wire gauges. Crimp connectors are used for making permanent connections between wires. They are typically used in applications where vibration or movement is a concern. Terminal blocks are used for connecting wires to electrical equipment, such as circuit breakers and switches. They provide a secure and organized connection point. The importance of professional electrical work cannot be overstated. Licensed electricians have the training, experience, and knowledge to perform electrical work safely and correctly. They are familiar with the NEC and other applicable codes and standards. Hiring a licensed electrician can ensure that the electrical system is installed and maintained properly, reducing the risk of electrical hazards. When hiring an electrician, it is important to check their credentials and ensure that they are licensed and insured. You should also ask for references and check their reputation online. A qualified electrician will be able to assess electrical needs, recommend appropriate solutions, and perform the work safely and efficiently. Regarding the specific situation, the initial assessment highlights several critical issues that need immediate attention. The current grounding configuration, relying solely on the solid strand cable to the power pole, is a significant safety concern. Modern electrical codes mandate the use of copper grounding rods or water pipe connections to ensure an effective ground. Without a proper grounding system, the risk of electrical shock and damage to equipment increases substantially. The incorrect connection of the ground wire to the neutral lug at the meter is another major problem. This misconfiguration creates a dangerous situation where current can flow through the neutral wire instead of the intended ground path. This can lead to overheating of the neutral wire and increase the risk of electrical fires. The jumper connecting both breaker lugs in the main panel is also incorrect. This essentially defeats the purpose of having separate breakers, as current can flow through both circuits even if one breaker trips. This can overload the circuits and increase the risk of electrical fires. The capped-off red wire should not be left loose in the box. It should be properly terminated and connected to the unused breaker lug if required. Leaving a loose wire in the box can create a potential hazard, as it could come into contact with other wires or metal components, causing a short circuit. To rectify these issues, a systematic approach is necessary. Firstly, at the meter, the ground wire must be removed from the neutral lug. The neutral wire should be connected to the neutral lug, and the red wire should be connected to the other hot lug. This will ensure that the neutral and ground wires are properly separated and that the red wire is available for use as a 240 volt circuit. Secondly, at the main panel, a copper grounding rod should be installed and the panel should be bonded to the water pipe. The jumper connecting the breaker lug should be removed. The red wire should be connected to the unused breaker lug, and the neutral wire should be connected to the neutral bar, which is bonded to the grounded panel. These corrections will ensure that the electrical system is properly grounded and that the circuits are protected by separate breakers. In addition to these immediate corrections, it is important to consider whether the existing 100 amp service is sufficient for future electrical needs. As homes become more reliant on electrical devices, a higher amperage service, such as 150 amps or 200 amps, may be necessary. Upgrading the electrical service can provide increased capacity for new appliances, air conditioning units, and other electrical equipment. Finally, it is crucial to have a qualified electrician inspect the entire electrical system to ensure that it meets current electrical codes and standards. A thorough inspection can identify any hidden problems or potential hazards that may not be immediately apparent. The electrician can also provide recommendations for improving the safety and efficiency of the electrical system. When working on electrical systems, safety should always be the top priority. Before beginning any work, always turn off the power to the circuit at the main panel. Use appropriate safety gear such as gloves, safety glasses, and non-conductive tools. If not comfortable performing these corrections, it is best to hire a licensed electrician to ensure that the work is done safely and correctly. Electricity can be dangerous, and it is important to take all necessary precautions to avoid injury or property damage. The role of the neutral wire is to carry the unbalanced current back to the source. In a 120-volt circuit, the neutral wire provides a return path for the current that flows through the hot wire. The neutral wire is typically white or grey in color. The role of the ground wire is to provide a safe path for fault current to return to the source. The ground wire is typically bare or green in color. In the event of a fault, such as a short circuit, the fault current will flow through the ground wire back to the source, tripping a breaker and disconnecting the circuit. This helps to prevent electrical shock and fire. The importance of bonding refers to the process of connecting all metal parts of an electrical system together to create a continuous electrical path. This includes metal conduits, metal enclosures, and metal equipment. Bonding helps to ensure that all metal parts are at the same electrical potential, which reduces the risk of electrical shock. Bonding is typically accomplished by using bonding jumpers, which are short lengths of wire that connect the metal parts together. The location of the service disconnect is typically located at the main electrical panel. The service disconnect is the main switch that is used to turn off all power to the building. It is important to know the location of the service disconnect in case of an emergency. The grounding electrode conductor connects the grounding electrode system to the electrical panel. The grounding electrode conductor is typically made of copper and must be sized according to the size of the service entrance conductors. The grounding electrode conductor is connected to the grounding electrode system at one end and to the grounding bus in the electrical panel at the other end. The grounding electrode system typically consists of one or more grounding electrodes, such as grounding rods, water pipes, or metal building frames. The grounding electrodes are buried in the ground and provide a connection to the earth. The grounding electrode system helps to stabilize the voltage of the electrical system and provides a path for fault current to return to the source. In conclusion, addressing these electrical issues requires a comprehensive approach that includes correcting the wiring errors, upgrading the grounding system, and ensuring that the electrical service is adequate for future needs. The most important consideration is safety. If not comfortable performing these tasks, it is best to hire a licensed electrician to ensure that the work is done safely and correctly.